Hello and welcome back to the Blade of Akai channel. You are watching Shenzhen IO and we are now moving on to some new products. We had that horrible thorium mining device efficiency improvement thing that kept me stumped for ages. But thankfully I'm through that one now. So on to the next. Cool Dad. Color changing vape pen. What? So Joe says, hope y'all are sitting down right now because this one is going to be big. How big, you ask? Well, you might just be talking to the guy who negotiated a deal to make all of the light up color changing vapes that Cool Dad is going to give away on this year's global tour. Dang! Am I right? This is a huge deal for us. Literally millions of these are going to be given away. So Carl goes on to say, looks rather straightforward. We get color values in, then we control some LEDs to get the shade we want. I put a bunch of extra LEDs in the prototyping bin too, since those should be fun to play with. Little tip for you, see the little triangle at the beginning of an XBus data packet? That's when all of those values in that packet are coming in. It's not like it's one per time unit, yeah? Shame that Cool Dad's actual music, if I can even call it that, sounds like 2008 era dubstep crossed with a parliamentary debate, if Parliament were popular entirely by screaming macaws. I have no idea why he's famous. And then David says, my girlfriend Xiao Mei is a fan. Some of it is quite danceable. Okay, create a working design for this product. Let's do it. So, first things first. So, CCVP D1. Open design. Right. So I guess this is our LED block. Radio RX is a non-blocking X-bus input connected to a radio receiver. LED R, LED G and LED B are simple outputs connected to an ultra bright RGB tricolor LED from top to bottom. RGB, I guess. So you can't see what I'm doing there. I'll move this over so we can do that. So RGB, I think. Right. And looking here, when a data packet is received over the radio, pulse the LED as specified. LED R intensity, LED G intensity, LED B intensity, pulse duration. But it's got no values in it. If a data packet is received while a pulse is in progress, interrupt that pulse. Interesting. Right. Right. So I'm just trying to understand. This is what we're expecting, right? Let's use one of these a minute and then just move 50 to P1 and then sleep one. It is not connected. No. Right. Let's do that and then yeah. So output pin rather than X-bus, but I mean there's going to be a lot of logic, I guess, in trying to determine what value we are storing right now, or what value we're receiving. So this is like a sequence, right? RGB, then duration. But the thing is, we've got one DAT value over here on the MC6000. So, I mean, effectively what we could do is, let's say we're going to receive the RX there, and we're going to sleep on RX. Sleep. Ooh, I can't type again. Right, sleep on X0. Then I just will move X0 to AC no matter what, just so we've got the value, and then we can say test equal AC minus 9999, right? 999, and then if so, jump to end, perhaps end sleep 1 maybe, and then there's gonna be like a time element to this. I'm not sure how that's going to work. Right, so basically if I sleep on X0 and X0 is minus 999, then we go to sleep. In fact, what I'll do is maybe say move 1 to AC and then jump to end and then sleep for AC. Otherwise, which we don't need to have any conditioning for, we can then just say the first, if it's non-999, the first value we receive is red. Okay. Right, okay. I think, yeah, in the very least I need this set up. Yeah. I need to have 3 different actual pins. Let's just do this. Right. That's not gonna work, is it? Right. Let's move this right up here. Let's move that right up there. And then we're gonna have that there. We're gonna have this coming into there. We're gonna have that going into there. So this is R, this is G, and then I guess, I don't know, we could maybe do something funky with this. So we could say basically SLX X0, move X0 to AC, test less than AC and then 0. If it's less than 0, then if it's not, let's say if it's not less than 0, then we will say jump to send, and then send will be move AC to no, okay, I have to do this by color. So if it's less than 0, RGB, so blue. Okay, so we're going to need to move the AC to P0 for blue. Yeah. Otherwise, we're going to have to, and then we're going to have an end statement in there, and then we're going to have to say mul AC neg1 move AC to P1. Okay, because if the hang on a minute, if it's not less than, sorry, that should be green, and that should be P1, that should be P0, right? So if it's blue, right, the value will be a negative value, but we need to convert that negative value to a positive value, so we'll multiply by neg1, and that should turn the negative value into a positive value. Otherwise it's a positive value and that is green, and we'll move the value straight to P1, so RGB. Okay, so this is depending on, oh, that should be green. So this is all depending on a valid signal coming out of this logic here. Now, so the first value is going to be red, right? Right, I think I'm going to need some reset code or something, but I'll cross that bridge when I come to it, I think. So the second value, I can save a step here actually. The second value, I can just move it straight away, move x0 to x2, so I don't need the ACK bit there. This one I do, so I need to move ACK to x2, which is now a negative value. Sleep for the amount in ACK, which will be after which, yes, after another wait. Now this is obviously not going to work first time. Oops, I forgot a jump. Okay, well we'll sort that out in a second. Move ACK to P1, 50 to P1. Well, that's right, according to this. And then we've moved minus 100, which is correct. It's less than 0, so we'll multiply that by -1, which gives us 100. Move ACK to P0, which is correct. And why is that now 100? Oh, right. Yeah, it's that jump. Okay, right. So I'm missing this jump. Jump to end. Right. Let's just check that bit now. 999. Yeah, 50 and 100. But now we've got, why did we have 100 up here? Yeah, because this logic is constrained. I'm going to need several boards, I think. Okay, I think I'm getting somewhere close with this design. However, I think I'm using too many boards. But basically I needed to work out some kind of timer function over here, because if you send 999 it means just keep the signal going till you receive another signal. If you get, say, a value of 4, then you need to run that for 4 seconds and then turn it off again. Now that obviously overcomplicated this first board, and I was having all this kind of trickle down effect, but I'm just thinking now that I don't need 3 different boards perhaps. What I could potentially do is if I move that there and that there, just so I've got them for reference, and then I'll move that out of the way, and then I can say, so P1 is the R value. Right, let's tidy this up a little bit as well. So let's put that there. P1 is there. P0 could be the green bit. We can switch that back around, get rid of all of that, and then put the RX straight into X0. And then obviously this first value should now be P1, and that needs to be replicated over here. The second value is P0 for green, and that needs to also be replicated down here. And then what we do need is just a simple board that can take that can take the output from X3 for the blue value and throw it straight, yeah, let's do that there, P1 there, and throw it straight into X0 on here for blue. And that's, I'm hoping, fingers crossed we've got this nailed now. Look at that. It's a thing of beauty. I can't believe I got that to work. Now, it's just not a very efficient design. And as you can see on the power usage, we're not doing so well. But the cost is good. The cost is fairly low. So I'm not sure what I would need to do to get the power down. But it wouldn't let me use stuff down here, and I think the DX300 probably could have come in handy in some way, maybe. I don't know. Anyway, let's return back to the email. And what have we got here? So Lily Wu says, greetings all. With every project we take, there are factors we can control and factors we cannot control. We could not control the fact that Cool Dad was arrested and jailed for possession of amphetamines as he attempted to enter Japan, thus cancelling the world tour. However, there was something under our control, and that was the terms of the deal. We could have negotiated a better contract that would have allowed us some recourse if something like this happened, instead of leaving us on the hook with 100,000 useless colour-changing light-up vapes for us to dump at basement prices just to get rid of them. Well, I think if Cool Dad got himself arrested, that would raise his profile even more, and those things will shift. So, I don't know what she's talking about. Anyway, what's this here? From Carl Teskey. Undocumented instruction. So I was chatting with a mate at the pub, and it comes to light those Chengshang microcontrollers we use everywhere have a secret instruction that isn't in any of the documentation. Takes the format of Gen P RI. Register or integer, P is a pin. So, and it conveniently generates a pulse on any simple I/O pin. The signal switches on 100, then off on 0 for however many time units you want using the last two operands. Gen PXY is equivalent to move 100 to P, sleep X, move 0 to P, sleep Y. Bloody hell, I could have been using this all along and saved so many instructions. Jay, did you know about this? Yes, actually, it is in the documentation, the Chinese version, just like the at conditional. The what? Seems like many instructions are not translated yet. Putting an at symbol at the beginning of an instruction causes it to execute only once. How have you been initializing code? Gee. Yeah, okay, I see how it is. Okay, so if we use the at sign, we can effectively get an init label without any jumps. That's amazing. That will save instructions. And the gen thing, yeah, I bet we're going to need something like that. So we're going to have to remember this. Anyway, let's move on to the next design. The 3 Kingdom tokens. Token-based payment kiosk. So this is from David P. Solomon. To my fellow expats, have you gone to a 3 Kingdoms land yet? I just went to the one in Shenzhen. The recreations of ancient Chinese society there are extremely fascinating. You even get old metal coins that you have to use to buy things with, as if you were really in the past. I watched the reenactors take my coins and then count them by hand. Isn't that bizarre? I thought they could use coin machines to count the money faster, so I negotiated a deal with them to build some here. Carl Teskey says, wouldn't a coin machine be a little out of place at a theme park that's supposed to be a historical recreation? And David goes on to say, Carl, I've already spoken to them about the look. The machine will have a beautiful carved faceplate design with dragons and heavenly mountains and all that stuff. It won't look out of place at all. The machine just has to know when you've put in the right coin total, such as the price of one, whatever that is. It rings a bell to let the person behind the counter know to hand you your item. Then it makes change in real physical coins. It's really like bygone times. Okay. Create a working design. Let's go. Have at it. Right. So I'm just going to call this TPK, Token Payment Kiosk, D1, and let's get in there. Okay. Right, so looking at this, we're saying in 1, in 5 and in 12 are simple inputs connected to a mechanism that accepts and detects 1 yuan, 5 yuan and 12 yuan tokens. Maybe? Is it yuan or is it the yeah, no, those aren't yuan, are they? Maybe that's the like cents or whatever equivalent. Bell is a simple output connected to a solenoid that rings a small bell when triggered. Out 1 and out 5 are simple outputs connected to a mechanism that dispenses 1 and 5 whatever tokens as change. Right. After a sufficient number of coins have been inserted, the payment kiosk should ring the bell and dispense change as indicated in the verification tab. The cost of the item is set by the operator using a switch that can be read as an X-bus input. So this is the switch, I believe. So that's saying that the price is 16. Okay. Well, it's 16 initially here, isn't it? Alright, let's take a look at the verification tab just to get an idea of the stuff coming in. Right. So bell. There we go. So if I put in a 12 coin and put in another 12, I've exceeded this value, which is 16. So the bell should raise. So that piece of the logic is fairly simple. I'm gonna have to have, I guess, P0 there, P1 there, have another one here maybe for P0, and then I can't fit that there, so let's do no. I mean, obviously this is where our pulse bit comes in, because I just want to do a pulse to output the change. The problem is always the number of pins coming in. You know what, actually I think if I get rid of that and then put one of these in place, right, and then I've got, so the price can come in on X0, X1 can deliver us the values here. So if I just say test equals P1 100, yes, move, I guess move 5. I think I want, yeah, I want to use this one as well. So no, I don't need to use that one. I want to move 0 to AC upon each sleep, and then I want to say move, so if P1 is 100, means the in 5 is high, so we move 5 to AC. Then we can say tech P0 100. We can then add 12. Okay. In fact, we can just say add there as well, and do that. And then at the end of all of that, we can then say move AC to X1, sleep 1, as such. Add, no, we don't say AC there, we just say add. Right, so that deals with in 5 and in 12. Now, over here, we would want to say, I guess we would want the same. For the AC at least, move 0 to AC, and then we would test. We would test P0 equal to 100. If it is, then add 1. Then we would need to sleep on X2, and then we would need to add X2. Then at the end of all of that, we would then need to sleep on X0. How do we do this? Test less than, right? Test less than X0, X0. Right? If it is, I'm not sure if I need this sleep here at the moment. I can comment that out for a minute, because I'm not 100% sure I need that one just yet. If the accumulator is less than I think what I need to do now is move AC. No, I need to. I think I'm not sure actually. Well, after a lot of messing about with different designs, I'm going to save you. I'm going to spare you the boring troubleshooting I've been doing and different designs and whatnot. I ended up going up to 4 boards, and but now I managed to get this down to 2 of the MC6000s. I've got a bit of a part sleeping problem that I'm just about to fix. Hopefully I can get this fixed. Yeah, it's blocking there. I'm not sure, but basically you can see I'm using the DX300 to receive the inputs from the pins. What's going on here? I seem to have some logic that's not quite right here, and it's causing a block. Yeah, so this is sleeping for 1, then jumping. I wonder if I can just change this code at the end of the loop and move it from basically this jump to the reset. Instead of having it at the end, we'll have it at the start of the loop. Okay, this is going through so far. This is the problematic bit here. Okay, so we're now in the second board. Loop end, jump loop, test, reset. yeah, that seems to be working now. Can we move forward with this now? I think we have a winner. And we managed to do this. Fingers crossed. Looks like it's going through. So we managed to do this with 2 MC6000s and a DX300. Not bad. Right, so we're on point with the cost, but again, the power usage, we're on the back of the curve. Yeah, I'm not sure what I could do to kind of make that more economic. I thought I was doing pretty well getting it down into the 2 boards, but there you go. Anyway, let's return to email. So, David says something, and then it is a small start, but like us, whoever it is, has global expansion in mind. As it is said, whatever that is. Thank you so much for your ancient wisdom, David. And he says you're welcome. I'm detecting sarcasm there. I don't think David is. Maybe I'm reading into this too much. Anyway, that's it for this episode of Shenzhen IO. We've done a couple of designs there. Cool Dad vape pen and a 3 Kingdoms token counting machine. So, I hope you liked it. If you did, don't forget to hit like, share and subscribe. Don't forget to comment down below if you think of a better design, and I shall see you all in the next video. Thanks for watching and bye bye for now. Human hack. What? What the hell? What the hell? O2 supply activated. Acceleration certificate.